Uniform cost search in Python. I have implemented a simple graph data structure in Python with the following structure below. The code is here just to clarify what the functions/variables mean, but they are pretty self-explanatory, so you can skip reading it. Now I am trying to implement a uniform cost search, i.e. a BFS with a priority queue, guaranteeing a shortest path, which starts from a given node V and returns a shortest path, in list form, to one of three goal node. By a goal node, I mean a node with the attribute is _goal set to true. This is my implementation. Now, after lots of testing and comparing with other algorithms, this implementation seemed to work pretty well, up until I tried it with this graph. For whatever reason, UXG, V, returned the path H, I which costs 0.87, as opposed to the path H, F, I, costing 0.71. This path was obtained by running a DFS. The following graph also gave an incorrect path. The algorithm gave G, F instead of G, E, F, obtained again by the DFS. The only pattern I can observe among these rare cases is the fact that the chosen goal node always has a loop. I can't figure out what is going wrong though. Any tips will be much appreciated.
Usually for searches, I tend to keep the path to a node part of the queue. This is not really memory efficient, but cheaper to implement. If you want the parent map, remember that it is only safe to update the parent map when the child is on top of the queue. Only then has the algorithm determined the shortest path to the current node. Note, I haven't really tested this, so feel free to comment if it doesn't work right away.
A simple check before expanding the node can save you duplicate visits.
If you want to see more, please contact Schuberts.